Hello dear little champions, welcome you all to this day 17 of 99% in 99 days in your class 10th board series. So today we are going to discuss the second chapter of science, that is acids, bases and salts. Okay, so this is going to be the part 1. So let us discuss what we are going to study today. So in this lecture we are going to talk about acids, bases and the pH. Okay, there will be a second part of this series. In the next class I'll be teaching you about salt. Okay, so now if you see in part 1 we'll be discussing about the chemical properties of acids and bases and the strength of acids and bases, that is pH, right? Now in chemical properties of acids and bases we have first of all here what is acids and bases we will discuss. So one second. Yeah, first we will discuss what is acid and base. Next we'll discuss briefly about indicators, then reactions of acids and base, this is the most important topic, then common in acid and bases. Okay, these are the topics that we are going to discuss under chemical properties of acids and bases. Next, coming to strength of acids and bases, in this we'll be talking about the pH scale and the importance of pH in everyday life. Okay, this is also very important from where you can expect questions. Okay, so let us start here with the first topic, that is acids and bases. So let me define you what is an acid. So very simple thing, acid is something which can donate hydrogen. Okay, any substance which can donate hydrogen is called as an acid. Okay, now how can you test or how can you check that it is an acid or base? So for that we need something called as indicator, and we use litmus paper here. Okay, you might have used litmus paper in your labs, or you have seen these are small strips of papers. So for acids, if the solution is acid, then what happens? Blue litmus will turn into red. You can see example here. See, now suppose I am dipping this litmus paper into the solution. The part which is dipped in the acid solution has turned red. The upper part which is not dipped in the solution is still remaining blue, right? That means when you dip a blue litmus paper in an acid solution, it turns red. Okay, so that is how you can identify that the given solution is an acid or a base. Okay, so next one, examples of some acids. You can see HCl, HNO3, these are your examples of acids. Now acids are also produced in human body. Okay, while digestion there is so many acids are produced by the stomach to digest the food. Similarly, when you do workout also, body releases acids. Okay, so apart from strong acid in our stomach, human bodies are known to produce lactic acid while exercising. So this you have to remember, this is important. Which acid is produced during exercise? That is lactic acid. Okay, fine. So next we'll define about bases here. Okay, so bases are the chemical substances which have a bitter taste and soapy to feel. Okay, they are generally bitter in taste and the texture can be soapy. Now if you talk about how can you identify a base, right? Now for acid we used blue litmus turns to red, and in base it is opposite. Red litmus turns into blue in the presence of a base solution. So example you can see here, suppose this is a basic solution. Okay, I have dipped a red litmus to it. The part of the litmus paper which is dipped in the solution has turned blue. Okay, and the one which is above it is still remaining red. So that means in the presence of a basic solution, our red litmus changes to blue. Okay, fine. Next examples we have NaOH. So if you see NaOH, if it dissociates you get Na plus and OH minus, right? OH minus are produced. So acid is something which can produce H plus and base is something which produces OH minus, which produces OH minus ions. Okay, clear? Fine. Now we will go to something called as indicators. So indicators are the things which can tell you whether a solution is acid or base. They will indicate that whether the given solution is an acid or base. One of the indicator that we have already seen is your litmus solution. Okay, the first indicator that we have already discussed is your litmus paper, or you can say litmus solution, right? And litmus paper in the acidic solution, what is the change? In acidic solution, blue turns to red, right? And in the basic solution we have red turning to blue. Okay, and there is another also pH paper is there. Okay, this I will discuss when we are going to discuss about the strength of the acid. So pH paper can also tell you about the acidity of the solution. Okay, this I will discuss in detail later. Okay. Now this is something which you can identify by vision, right, by seeing it. Now how can we identify, suppose for example a blind person is there, right? How can they identify? They cannot see, right? So for that, or there are certain smell by certain indicators are there, or certain things are there whose smell changes in presence of acid and basic medium. So those type of indicators are called as olfactory indicators. Okay, so olfactory indicators means those substances whose odor, or you can say smell, okay, changes in acidic or basic medium are called as olfactory indicators. Now example, vanilla, onion, clove. Okay, the smell of onion and vanilla diminishes in the base and remains as it is in the acidic medium. Okay, so in the acidic medium the smell remains same, but in the basic medium the smell reduces or the odor reduces. That is how you can identify whether it is an acidic medium or a base medium. Clear indicators. Next we will go to the chemical properties. Okay, so under this we are having three things that we are going to study: reactions of acids, reactions of bases, and reactions of acid and base with each other. Okay, so first under reactions of acids we have reactions with metals, with carbonates and bicarbonates, with metal oxides, and in case of reactions of bases we have with metals and with non-metal oxides. And here we will be studying about reactions of when acid and base will react with each other. Okay, so this is very important table, you need to remember this. Acids, three reactions we will study: with metal, with carbonates and bicarbonates, and with metallic oxides. For bases we will study two reactions: with metals and with non-metallic oxides. Then coming to the third type of reaction is reaction between one acid and one base, how they will react with each other. Clear students? Now let us move forward and see the reactions of acids. Okay, so first we are studying reactions of acids with metals. Okay, so this is very important. Acid reacts with metals to give you salt and hydrogen gas. This is very important, hydrogen gas. For example, if Zn is a metal, okay, reacting with an acid, right? So what we will get first, that is ZnSO4, which is a salt, and then a hydrogen gas. Okay, now there is something to determine this hydrogen gas. You can see bubbles coming out. Okay, you can easily see. So if you can see this picture, what I have taken in this test tube, okay, test tube, there are some zinc granules, okay, and then we added some sulfuric acid to this. When these two are added, you can see bubbles of gases are produced. Okay, these bubbles of gases are produced are nothing but hydrogen gas bubbles. Now what I did is I allowed this hydrogen gas bubbles to come here. Now these bubbles are there. Now if you bring a matchstick here, okay, a matchstick if you bring, the hydrogen gas will burn. Okay, in presence of oxygen and fire, the hydrogen gas will burn and it will produce a characteristic pop sound. Okay, if we know that a pop sound is being produced, that is an indicator that hydrogen gas is produced. So whenever metal reacts with acids, hydrogen gas and salt is formed. Okay, now let us see the second reaction with carbonates and bicarbonates. So here what are the byproducts? Salt is formed, water is formed, and carbon dioxide is formed. Salt, water and carbon dioxide. Okay, now example, if you see sodium carbonate with HCl, okay, this is a carbonate and reaction of acids with carbonate. So first I will get a salt, NaCl, then we will get H2O, and then we will get CO2. With bicarbonates, NaHCO3 and HCl, the same we will get NaCl, okay, then we will get H2O and CO2, NaCl plus H2O plus CO2. Clear? Fine. Now coming to this one, we have you can see this example. We have this one, you have taken some sodium carbonate, okay, and with sodium carbonate you have taken dilute hydrochloric acid. Now with sodium carbonate and dilute hydrochloric acid, what happens? this carbon dioxide which is produced, okay, you allow that carbon dioxide to come to pass through this tube, and in the tube you have taken calcium hydroxide solution, okay, calcium hydroxide solution. So this carbon dioxide, okay, produced reacts with calcium hydroxide, okay, to give you calcium carbonate and water. Okay, now due to this formation of calcium carbonate, this solution turns milky. Okay, this is how you can test the presence of carbon dioxide. Remember how to present the test of hydrogen gas? You need to bring a matchstick, it burns with a pop sound. How to test the presence of carbon dioxide gas? So for that you need to pass the carbon dioxide gas through calcium hydroxide solution, and then you see that the calcium hydroxide solution turns out to be milky, and that is due to the formation of calcium carbonate. Okay, now we will see the next reaction, that is reactions with metal oxides. Okay, so with metal oxides it forms salt and water. For example, you can see copper oxide with HCl will give you copper chloride, this is your salt, okay, and water is produced as a byproduct here. Clear? Now once again let us revise this one. Acids will react with, first we learnt with metal, okay, it will give you salt and H2, right? Then with carbonates and bicarbonates, I am writing the formula. Here we will get salt, CO2 and water. Then if it is reacting with metal oxides, okay, you will get salt and water. Okay, these are the reactions for acids. Next, if you see reactions of bases, okay, the first is reactions with metal. So again, when bases will react with metal, the same product is formed, salt and hydrogen gas. Example, you can see NaOH and zinc. Okay, here this salt is important, Na2ZnO2. This is called as sodium zincate. Okay, Na2ZnO2. This is important, plus hydrogen gas is produced. Okay, next if we see the reaction is with non-metallic oxides. Okay, base plus non-metallic oxides will give you salt and water. So we have base here, calcium hydroxide, and with a non-metallic oxide. So carbon dioxide is what? Non-metallic oxide. Non-metallic oxide. Right. So first a salt will form. So salt formed here is calcium carbonate, and with that water is produced as a byproduct, calcium carbonate plus water. Okay, so for base water, let us revise the reactions again. So base, if you are reacting with metal, okay, we get salt and H2, and with non-metal oxides, okay, we get non-metal oxides, okay, we get salt plus water. Clear? Okay. Now we will see what is happening when acids and bases react with each other. Okay. So when acids and bases react with each other, that type of reactions are called as neutralization reaction. And what is the product formed? Salt and water. Okay. You can see the example, calcium hydroxide is a base. Why? Because they produce OH minus. Here HCl is an acid. Why? Because it produces H plus. Now these two will react to give you salt and water. Right? So that is called as a neutralization reaction. Okay. Next, coming to something about common in acids and bases. Till now we have seen so many differences between acids and bases. The first is acid is sour in taste, bases are bitter in taste, acids produce H plus, bases produce OH minus, acids turn blue litmus to red, bases turn red litmus to blue, right? So these are so many differences between acids and bases. But is there anything which is common between an acid and a base? Is there anything that they have similarity between them? So that is what is very, very interesting. We'll see here. Okay. So both acids and bases are electrolytes, which means that they are good conductors of electricity. Okay. Acids and bases both can conduct electricity. That is why they are very good conductors of electricity. Okay. Acids and bases both produce ions in the water solution. Okay, when you put any acid and bases, they produce ions, and that is why they are good conductors of electricity. Okay, Next, so the ions produced by acids and bases are different. Acids release hydrogen ions, whereas bases release OH minus ions. But the common thing is they both produce ions in water. Okay, and that is why both are very good conductors of electricity. But acids will give you H plus and bases will give you OH minus. Okay. Okay, next, this is important, the process of mixing an acid or base in water. Okay, when you dissolve any acid or base in water, it is an exothermic one. So we have discussed what is exothermic in the chemical reactions chapter, right? So exothermic is the one where heat is released. Okay, heat is released. Clear? Okay. Now we will go to the next thing, that is strength of an acid or a base. Strength, how to tell that whether this is a very strong acid, strong base, weak base, how to tell, what can be used to measure the strength of an acid. Okay, that is very important here. Now see, the universal indicator shows different colors at different concentrations of hydrogen ion in a solution. Now this I will show you. There is something called as universal indicator or pH paper. Okay, I told you that I'll discuss pH paper in detail. So universal indicator is the one which tells you how much concentration of hydrogen ions are present. Okay, now see, a scale for measuring the hydrogen ion concentration in a solution is called as the pH scale, and it was developed okay, the P in the pH stands for potence in German, meaning power. Okay, so what is the concentration of H plus, or what is the power of H plus? That is given by the pH scale. Okay, now on the pH scale we can measure pH generally from 0 very acidic to 14 very alkaline. Okay, so the pH range starts from 0 to 14. Now you can see this diagram. When the pH is 0, that means it is very acidic, and acidic solutions will give you H plus. That means there is high concentration of H plus here. Now as we go along from 0 to 14, okay, the H plus concentration decreases. Okay, the H plus concentration keeps on decreasing, and there is a midpoint, that is 7. Okay, at 7 it is a neutral. I means here the H plus concentration and OH minus concentration are equal. Okay, so we will see this in detail. Okay, now see, higher the hydronium ion concentration, or you can say H plus concentration, lower is the pH value. Okay, the pH of a neutral solution is 7, and here you should remember that here the concentration of H plus is equal to the concentration of OH minus. Okay, value less than 7 on the pH scale represents acidic solution. As the pH value increases from 7 to 14, it represents an increase in the OH minus concentration in the solution, that is increasing in the strength of the alkali. Okay, so now if you see, this is the pH paper. Okay, you can see when the pH is 0, these are very strong acid. Okay, that means H plus concentration is very high. Okay, next we go slowly towards lemon juice. Okay, here the pH is 2.2, so here the pH was 1.2 for gastric juice. So where is the H plus concentration higher? Now see, gastric juice is more acidic, its pH will be less. The first statement you can see here, higher the hydronium concentration, lower is the pH value. So I can write stronger acid, okay, stronger acid has low pH value, and I can say they have high H plus concentration. Okay, so that means gastric juice, which has a pH of 1.2, is more acidic than lemon juice whose pH is 2.2. Now in terms of H plus concentration, gastric juice will have more H plus ions than compared to lemon juice. Okay, now if you compare pure water, okay, or blood, the pH is 7.4 something. And now if we move towards this side, okay, here the range is basic solution. Okay, here H plus concentration is less and OH minus concentration is increasing. Okay, so pH 14 means very high concentration of OH, okay, and strong base. Okay, so here one more thing I'll tell you, stronger base, okay, if it is a base, stronger base, then you have high pH value, not low pH value in case of acid, right? So stronger base means high pH value and high OH minus concentration. Okay, these two things are very, very important. If pH is decreasing, that means acidic nature is increasing. If pH is increasing, that means basic nature is increasing. I hope this is clear. So 0 to 7, 0 to 6.9 is acidic nature, 7.1 to 14 is basic nature, and 7 is the neutral point. Okay, neutral point means where H plus and OH minus are equal. This side H plus is more, this side OH minus is more. At the middle, H plus and OH minus are equal in concentration. Okay, fine. Now we will see some everyday life where pH is very, very important, but we generally ignore it. The first thing is animals and plants are pH sensitive. Okay, so now what happens when acid rain takes place? Okay, its pH is below 5.6. This value you should know. Acid rain pH is below 5.6. Now when this rain water goes to sea, river and other water bodies, they decrease the pH of the water body also, right? Now it means the water bodies become more acidic, and that is why the aquatic animals staying in the water bodies are affected. Okay, so that is how the acid rain causes death of the aquatic animals. Okay, next, pH of the soil affects the growth of the plant. So we need a very balanced pH for the growth of the plants. If the soil is becoming more acidic or more basic, then the growth of the plants is affected. Okay, third is pH in our digestive system. Now see, generally what happens, our body, okay, releases acid to digest the food. Okay, now in certain cases what happens, sometimes the stomach releases more acid. Now the theory behind here is we have a routine of food, right? We take food at a particular time generally. Okay, so with that our body also releases acids to digest that food. Now in case you haven't eaten food at that point of time, you didn't take your food, then what happens, the acids are released by the stomach. Okay, but there is no food to digest that, there is no food to use that acid to get digested, right? So in that case what happens, we suffer from a disease called as, not a disease, or symptom called as acidity. Okay, when more amount of acid is produced in the stomach. So to cure this, or to prevent or to neutralize this acid, we need to take some bases. Okay, and these things that we consume to neutralize the acid that is produced in the body is called as antacids. Okay, antacids are used in for digestion in case of acidity. Okay, now antacids, generally the main constituent of antacids is milk of magnesia, that is nothing but your magnesium hydroxide. Okay, clear this one? Okay, next coming to tooth decay. Okay, now see again here, when you eat certain food, okay, and the food is left on your teeth, the bacteria is present in the mouth try to digest this or try to break down this food into smaller particles, and they release a lot of acid in your mouth. Okay, and this acid can dissolve the hardest substance present in your teeth, present in your body, that is your enamel. Okay, enamel will not dissolve in water at all, but in presence of acid the enamel can dissolve, and this leads to cavity. Okay, so that is why we should brush our teeth regularly. Now how does brushing teeth prevents it? The paste that we are using, right, the toothpaste, that contains base. Okay, so when you brush your teeth, you neutralize that excess acid present in your mouth. Clear? So when you neutralize this excess of acid present in your mouth, the acid is consumed, so your mouth again becomes neutral. Okay, so that is how you should remember here. And pH is less than 5.5. okay, so the mouth pH is generally, like when it is becoming less than 5.5, the acidic concentration becomes high, so your mouth starts, or your teeth starts to decay. Okay, now enamel is made up of calcium hydroxyapatite. Okay, you should know this name, it can be asked in MCQ. Next, self defense by animals. So generally when animals are disturbed, or you hit them or something, they bite you, right, and it causes severe pain. So that is due to acid released by the by these flies, bees and all. Okay, what is that acid they release? They release methanoic acid. Okay, so that your finger, suppose they bite you it in the finger, so the acid that is produced in the finger, like the acid that is produced in the string, okay, it comes and it causes swelling in your hand, right, or your finger. So to neutralize this, you need to add a base, and generally in this case we use baking soda. Okay, these are certain applications of pH in our daily life. First is the growth of plants. Okay, next, the acid rain causes disturbance in the growth in the life of aquatic animals. Third, we have tooth cavity. Okay, the cavities that we get, that is also due to pH. Fourth, we have acidity. Okay, how can it be neutralized? By antacids. Then fifth, we have the last one that we talked about, defense by the organisms. Okay, now we'll go to, okay, here one important announcement, students, for all of you. Now see, you are in 10th standard, right? And after this you are going to choose a career for you, and this is going to be a very, very important decisions, and you just cannot take it randomly. So it is always good if you take this decision of your life with proper guidance, right? So to help you with this, Diksha has come up with DSAT, that is abbreviated of Diksha Scholarship Aptitude Test. Okay, so in this what happens, here you have a 60-minute concept based lecture. Okay, there will be a lecture for 60-minute concept based, they'll teach you something, and after that you will be getting a aptitude test on that particular topic. Clear? Then you attempt the test. Once you attempt the test, then they evaluate it. They know your weakness and strength. Okay, they understand your strength and weakness, and then they personally guide you, mentor you, counsel you about which career is the best for you. Okay, so this is this is going to be really helpful for all those students. So if you want to know about this, so you can register for DSAT. The link is given in the description section, and definitely make use of this opportunity to select the best career for you. Okay, now moving forward to some practicing of questions. Okay, first question. So Anita added a drop each of dilute acetic acid and dilute hydrochloric acid on the pH paper and compared the colors. Which of the following is the correct conclusion? Okay, so acetic acid and hydrochloric acid. So hydrochloric acid is a stronger acid than acetic acid, and we have defined that stronger acid, if it is there, okay, stronger acid, right, will have low pH, right, and if HCl is a stronger acid than acetic acid, okay, then pH of HCl will be less than the pH of acetic acid. Okay, so let us see. pH of acetic acid is more than that of hydrochloric acid. Yes, that is correct, because it is a weak acid. So correct answer will be option number A here. Okay, next you can see this one. Zinc granules reacting with sulfuric acid. I think we have just discussed this diagram between reactions of metals with acids. So the question is, identify the gas A, okay, produced in the experiment. So you know the gas A here is hydrogen, right? Option number B is the correct answer. This question was asked in CBSE sample question paper of 2022. Okay. Next, question number 3. How will you protect yourself from the heat generated while diluting a concentrated acid? This is very important question. Now see, we have just seen one statement. If you have remembered, I'll show you what is the importance of this line. I can tell you now. Yeah, you can see the process of mixing acid or base in water is an exothermic one, means heat is released in that process, right? Now let us go back to our question. Yeah, now see what will happen. So you want to mix, suppose, acid and water, and we know that when we mix acid and water, huge amount of energy or heat will be produced. So the correct way of mixing an acid to water is, you should always add water, you should always add acid to water. Okay, means first you should have water, and then slowly, drop by drop, you need to add acid to it. Okay, so in that case, whatever heat is released, okay, this heat will be absorbed, by the water, and you will be saved here. But if you do the reverse, okay, you have taken acid and then you added water to that, in that case what will happen, a huge amount of energy will be released, and the test tube, beaker, whatever you have done, it will explode with that heat, right? So it is very, very important to add always acid to water. Okay, so Correct way is by adding acid to water with constant stirring. Yes, this is the correct way. So the correct answer is option number A here. Okay. Next is question, we'll go for some assertion reason question here. So hydrochloric acid and nitric acid are strong acids. Acids which ionize completely in the aqueous solutions are strong acid. Yes, so this is important, both are correct. Now what is strong acid and what is weak acid? See, strong acid dissociates or ionize completely. Okay. And weak acid ionize partially. Okay, so now they are strong acid because they do complete ionization, so that is assertion is correct, reason is correct. Reason is explaining the assertion, so correct answer is option number A here. Okay. Next is question number 2. The milk when changes to curd becomes more acidic. Okay. Lesser the pH value, more is the acidic nature. Yes, both the statements are correct. Okay. Lesser pH value, stronger is the acidic nature, right? But is it explaining this one? No, right? The milk when changes to curd becomes more acidic, that is correct here. Okay, but is it explaining here? Lesser the pH value, more is the acidic nature. Yes, now how can you see? See, suppose you have milk, okay, and you measured its pH. Suppose it is 1, okay. Now if it turned to curd, okay, now you measured it pH and it is 0.5. Right? Now it tells you that this has become more acidic. Milk has become more acidic because of what? Because the pH value has decreased. So again we can say both are correct and reason is explaining that. So correct answer is option number A here. Next is, we'll go to 2-marker questions now. Okay, so here are some important 2-marker question. First is, Aditi finds a mixture of an acid and a base which does not change the color either of red or blue litmus paper. Compare the amounts of H plus and OH minus. So if it is not changing color, if the litmus paper is not changing color, that implies that this solution is what? This solution is neutral. Okay, and in neutral solutions the concentration of H plus and OH minus is equal. So how can I answer this? So it will be, the question is, compare the amount of H plus and OH minus. You can say the amount of H plus and OH minus is equal. Okay, next question number B here. Every whole unit in pH represents a 10-fold increase or decrease in the hydrogen ion concentration. If you are moving like from 5 to 6, that means 10 times the hydrogen ion concentration has increased or decreased. Now what would be the hydrogen ion concentration of a solution of pH 4 be compared to a solution of pH 8? So pH 4 to pH 8. Okay, so I'll draw a number line, it will be more easy to explain like this. So you have 4, 5, 6, 7 and 8. So from here to here, right, every time there is an increase of 10. So here we have an increase of 10 to the power of 4 times, right? So what would be the hydrogen ion concentration? 10 to the power of 4 times. Okay. Next question number 2. Name the natural source of each of the following acids. So lactic acid is produced from your curd, okay, and tartaric acid is present in tamarind. Clear? Next question number 3. Okay, the pH is measured using a pH meter. You might have used this, or I don't know, but pH meter is a device to calculate the pH of the solution. Okay, which comprises a detecting unit consisting of a pH sensitive glass electrode and an indicating unit which indicates the pH as shown below to measure the pH of the solution. So here you can see like this, you have this rod is there, okay, you just need to dip the rod in the solution, okay, and then this box, or I can say this indicator is there where the direct value of pH will be given to you. Okay, so now, so what will happen? So what you should do is, to measure the pH of a solution, the glass electrode is dipped into the solution and the pH is displayed on the screen of the indicating unit. Okay, once you dip it, the pH value will be shown on this particular screen. Now before measuring the pH of another solution, suppose this is solution A, you want to measure the pH of another solution, what you should do is, the glass electrode is rinsed, this glass electrode is rinsed with distilled water and dried carefully with tissue paper. Okay, that is the process, and then you should dip the glass electrode in the second solution. Now the question here is, how is the pH reading of the second solution likely to be affected if the glass electrode is not dried with tissue paper in the following cases? Okay, if the second solution being measured is acidic in nature. Okay, now see, this is the pH rod. Okay, it is not washed or you have not dried it. Okay, that means what? It will have some water present in it, attached, some water droplets will be attached to it, okay, or stick to it. Now you have the second solution here, okay, which is acidic in nature. Okay, now what I'm saying is, when you dip this one in this one, right, so this water droplets which is present here will make this acid dilute, will dilute the acid. Okay, dilute the acid means the acidic nature decreases. If the acidic nature decreases, what will happen to pH? We know if acidic nature is high or acidity is high, pH is less, but if acidic nature decreases, pH will increase, right? So in that case, here what will happen? The pH will increase. Okay, so here what will happen? The pH increases, right? The reason you can write, when you dip it, the acidic solution is diluted, as a result of which the acidic nature is, you can say, it becomes weaker, right? The acidic nature weakens, and that is why the pH increases. Now in case this is a basic solution, okay, in case this is a basic solution, okay, now in basic solution again what happens? If you add some water, the basic nature will dilute. If this is dilution, then it becomes a weak base, right? If it is a weak base, then pH will decrease, right? You remember, for base, what is the condition? If weak base, less pH. If strong base, more pH, right? So when you are diluting it, that becomes a weak base, right? You add a more water, it became a weak base now. Okay, dilution means the concentration of OH minus will decrease. Okay, with per unit volume, the concentration of OH minus will decrease, and when it becomes weak, the pH will decrease. So that is why here the pH will decrease. Okay, clear? Fine. Next we'll go to next question. Yeah, this was the question that I have already answered you. So let me tell you in detail here. Okay, when the glass rod, okay, when the glass rod is dipped in acidic solution, the acid gets diluted, hence pH increases. Okay, same way you can write for the second part. Okay, next coming to question number 4. Dipti has 3 flasks containing dilute hydrochloric acid, sulfuric acid and dilute sodium hydroxide, okay, leveled respectively. The flasks are not leveled and she does not have any pH indicator. Okay, so it is like this. I don't, some error in the question, but this is like this. You have 3 beakers, okay, one is HCl, okay, and we don't know but which one is HCl, okay, but it is told that, one second, okay, it is told that in one beaker we have HCl, in another beaker you have H2SO4 and in another beaker you have NaOH. Okay, now these are the 3 beakers and we have 3 solutions. We don't know what is present in what. Next, if you see, which of these solutions will she be able to identify just by making mixtures of pairs of the substances? Okay, so we know, suppose this is A, this is B and this is C. Now we know that there are 2 acids and 1 base, right? So when you mix, suppose these 2, if you mix, okay, you cannot find any difference there, but if you mix these 2, okay, then definitely you can know that one of them must be acid, because must be base, because there is a neutralization reaction happening. So which one we can easily identify? We can identify the NaOH solution. Okay, so we can identify the, sorry, yeah, so we can identify here which solution, the NaOH solution. Okay, now how can you identify that? What observation will help her to make this identification? Whenever you take one acid and a base, okay, the is an neutralization reaction, exothermic reaction, the beaker becomes hot. Okay, so you can write down here, the beaker becomes hot. Okay, that is how you can identify. Next, to prepare a salad dressing, Parag adds a solution of sodium chloride in distilled water to vinegar. So first what he makes, sodium chloride he added to distilled water. Okay, here suppose water is there, and then this one is added to vinegar. Okay, state what change will occur with the following: pH of the vinegar. Now see, again what you are doing, you are diluting it, right? You are diluting it. Diluting it means it will become a weak acid, or like whatever, it will become much weaker acid. If it is becoming a weaker acid, pH will increase. So what will happen to pH? pH will increase. Okay, but what about the acidity? Because you have diluted it, so acidity will decrease. Clear? Next, we'll go to 3-marker question. In the electrolysis of water, name the gas collected at anode and at cathode. So here you should remember, at anode, okay, oxygen gas is collected, and at cathode H plus gas is collected. Okay, next we have, why is the volume of gas collected at one electrode double than the other? Okay, so here if you see, if H2O is electrolyzed, we get H2. I can write the balanced equation like this, 2H2 plus O2, right? This 2 is to 1. So what is the volume of gas collected at one electrode double the other? So because you can see 2 units of H2 gas is produced with respect to 1 unit of O2 gas, right? So when the ratio is 2:1, then definitely the volume of gas collected to one electrode will be double than the other. So that is why this is because of this ratio. Next, what would happen if dilute sulfuric acid is not added to water? Now see here, distilled water does not conduct electricity. Okay, so if no H2SO4 is added, okay, then it will not conduct electricity. It will not conduct electricity. Okay, clear? Fine. Next, question number 2. You are provided with 90 ml of distilled water and 10 ml of concentrated sulfuric acid to prepare dilute sulfuric acid. Means you need to dilute the sulfuric acid. What is the correct way of preparing the dilute sulfuric acid? Give reason. So what the first is the correct way? Add 10 ml of concentrated sulfuric acid to 90 ml of water. Okay, now what is the reason for that? This is because when acid is added to water, right, heat is released. Okay, so if water is added to acid, then it may cause explosion, right? So that is why we need to add what? Acid to water. Next, how will the concentration of H3O plus ion change on dilution? So the concentration of H3O plus ion will decrease per unit volume. Okay, that is why pH will also increase. Clear? Okay, next question number 3. Sweet tooth may lead to tooth decay. Explain why. What is the role of toothpaste in preventing the cavities? So explain why. I have already explained you. When you eat food, okay, the remaining food particles, right, the remaining food on teeth are acted by bacteria to produce acid, right, to produce acid which can dissolve enamel, right, and cause cavity. Now to neutralize it, how you can do, what is the role of toothpaste? Toothpaste contains your base, right, so it can neutralize the acidity of the teeth. Okay, next we'll go to long answer question. State reason for the following statements. Okay, tap water conduct electricity whereas distilled water does not. The answer here is tap water contains ions, right, tap water contain ions whereas distilled water does not. Dry hydrogen chloride gas does not turn blue litmus whereas dilute HCl does. So you can write down, in dry HCl there is no H plus ion. Okay, so that is why it doesn't give you the color change. When you take dilute HCl means you have added water, H plus ions are produced, and these H plus ions are responsible for the color change in the litmus paper. Next, during summer season, a milkman usually adds a very small amount of baking soda to fresh milk. So that is because of, to prevent the souring of milk, due to lactic acid. Okay, so generally what happens when milk is there, it has an acid called lactic acid. Okay, so if you leave the milk for a certain period of time, this bacteria acts on this lactic acid and its concentration increases. Okay, and the milk becomes sour. Now if you add some baking soda to it, okay, in that case what happens, this baking soda neutralizes the lactic acid present in the milk, and that is why the milk can remain fresh for a longer period of time. Okay, next, for a dilution of acid, acid is added into water and not water into acid. So yes, this is because it is an exothermic process. We have discussed this in detail now. Okay, next, ammonia is a base but does not contain hydroxyl group. Now when you dissolve ammonia, okay, in water, you get NH4 plus and OH minus. So even though it does not contain OH ion, but when you dissolve it in water, it gives you OH minus ion. So that is why it is also a base, or it is also basic in nature. Okay, next, question number 2. A remarkable property of acid is that they can dissolve metals. When metals are added to an acid, they disintegrate and disappear into the acid. So state one other common observation with metals dissolving in acid. Explain the reason for this observation. The first reason here is gas bubbles are formed. You can see gas bubbles are formed. Okay, gas bubbles are produced, and this is due to hydrogen gas, right? When metals reacts with acid, hydrogen gas is liberated, and due to which you can find bubbles in the solution. Next, if the acid with the dissolved metal is evaporated, can we get the metals back? Why or why not? Okay, so answer for this is no, you will not get the metals back, but in certain case when group 1 metal solutions evaporate, we get the metal back. Okay, and in group 2 we will not get, but except beryllium you will get back the metals. Okay, next, in this question the word dissolve is used within quotes. This is because it is not actually an example of dissolving. What is the main difference between a metal dissolving in an acid and a sugar dissolving in water? Okay, so here you can see the metal dissolving in acid is a chemical process. Okay, it is very difficult to get back the metal again in its original state, whereas sugar dissolving in water is a physical change. Okay, if you evaporate, here we will get back the sugar definitely. Okay, so that is why it is a physical change, and dissolving of metal in an acid is a chemical change, and you also find new products are formed, hydrogen gas is produced, right? So that is why that is a chemical change. Okay, fine. So once again student, I want to remind you about DSAT. As I already told you, in your 10th standard, after your 10th standard, it is a very critical and important decision about your life and your career. So it is always good that you take some advice for some who are really experienced about it. So that is why there is DSAT, Diksha Scholarship Aptitude Test. So here you get a 60-minute of lecture, and then you write a test on this, and then it is evaluated, and the mentor guides you, tells you about your weakness, strength, and they also guide you which career is good for you. Okay, so if you want to take the advantage of this opportunity, then please register for DSAT. The link of the registration is there in the description section of this video. Okay, fine. So yes students, that was the part 1 of acids, bases and salts. Tomorrow we'll meet soon with the second part, where we are going to discuss about salts. So if you have liked this video, then please do not forget to subscribe the channel, and thank you for watching. See you soon in the next class.